My name is Tim Ryan. I am a occasional software developer of vintage consoles. Today I want to present a project that I've been working on for a few months called Pax Consola. I started doing retro gaming development very young. I think I was like maybe 10 or so when I first found assembly code and was like, this is really interesting, and C is really hard, but this is a machine I can sort of understand. And that was where I first got started looking at these old consoles as a way to really understand something in depth and really play around with something that seemed to have a bit of magic to it. And it took me a while to figure out why I felt it was magical to try to code for these old consoles. But the project today, just to skip to cut to the chase, is a website and IDE called PaxConsola.com. And if you have a laptop, you can go to that, but I'll be showing a demo later on the top of this page. But basically, it's a way to write games for many different consoles at once, and I'll go into why this is something I wanted to do. But first, I want to talk about the inspiration for it. So, especially over the pandemic, but over the past few years, I've noticed an uptick in myself playing games with pixel art. And so, pixel art games are 2D usually. They have very beautiful graphics. They have very limited color palettes, but they still manage to sort of evoke emotion. One of the games that I was really interested in was called Celeste. And so this is a 2D platformer that you can find on the Switch and other platforms. And it actually tells a story about a young girl who's going through, it's a story about mental illness, but you play it as a 2D platformer. And it's a very intensive one too. It's a very difficult one to sort of master. You're jumping around, you can go off of walls and things, but it's sort of a young girl working her way up a mountain and also processing the story as well at the same time. And I thought this was really cool. It sort of reflected what I was going through at the time, but part of it is actually, they did it in this pixel art style, which is very pretty and luscious and beautiful. And I thought that was really interesting that pixel art was the medium, and I think there's something to that beyond just, oh, it looks gorgeous. So pixel art is still very popular. It's 2021. We do not need to use limited resolutions or palettes for anything. But people are still attracted to this medium. So what makes you feel like you need to design a game in this art style? For me, it's sort of something that evokes nostalgia and excitement, especially when you're cracking open a video game as a young kid for the first time, or playing something new that you've been wanting for a long time. You've been seeing it, and then finally you open up that cartridge and get to play it. It also evokes a feeling of safety, I think. You're of a limited world, there's only so much you can do with it, and it feels really compelling to try to navigate through that world as opposed to a much more open-ended world. And I think this is the medium through which I found vintage consoles and vintage computers interesting. It's you get to sort of master this very tiny world, and in doing so, create or experience something that would be very hard on just a console that could power billions of pixels a second. I think there's also an element of pixel art is sort of reminiscent of different mediums that don't really exist anymore. So I have the example here of Pitfall 2, which is a game released for the Atari 2600, and then I think a few other consoles like the Commodore. But me and my older siblings would play this a lot as a kid. We loved the Pitfall series. And one of the interesting things about Pitfall is you're playing this character here, and the screen is sort of like a side scroller, where you can go from one screen to the next. But it only scrolls downward. And that's actually a limitation of the Atari, where it was a lot easier for them to design a game rather than Mario, where you're going from one screen to the next. You're plummeting down into this cavern. So it was sort of because the Atari couldn't render that much, it sort of emphasized what the game design had to be in order to be immersive. Or at least I always found that a cool element of the game. And so we could say that the unique graphics and processing capabilities of the console helped dictate what its design was. We can also say that we don't really have these constraints anymore, and does that actually change how we creatively relate to these consoles? And the creative expression that you have in these games is like really cool if you understand the limitations of the system, you know, how they had to work around these limitations to make something compelling. So I thought that, like, okay, so every console is sort of a medium. It's like, you know, a Game Boy game looks like a Game Boy game, a Super Nintendo game looks like a Super Nintendo game. What if you could use these canvases almost without having to dig through technical manuals in order to like get the most out of programming for them? And so that's sort of where this project originated, is like, how do we explore old consoles as a medium without having to like spend a lot of time researching into them? Another motivation I had is, like I said, I've been programming for a long time on these old consoles. One of the earliest things that I actually worked on was a game for the Channel F, which is a console that preceded the Atari. It was not very successful in the field, but it's a very interesting console made by Fairchild. And it was the first programmable console, and it was really cool because it had like a full bitmap addressable display and things, and you could actually make really interesting games. So while you go to the flea market, and if you see a Channel F game, it might be like, here's how to play poker, or here's how to play chess. The game that I worked on nearly 2 decades ago at this point was like, what if we ported Pac-Man in the system? Like, what if the flagship title of this console was actually Pac-Man? Like, it would have been way more successful out of the box if they had that licensing. So the first game I kind of worked on and helped another developer work on was actually a port of another game. So that's where I sort of started being like, oh, porting games is actually a really fun enterprise, seeing like old consoles do new tricks. So a few years now, I've been bored and been like, oh, you know, what if I took one game and I tried to port it to as many consoles as possible? And I've already done Pac-Man, so let's look at something else. Getting a game running on an old system is really fun. And I thought this would be a good way to say, like, all right, let's put aside the question of what the game is, let's pick something interesting, and just work through the mechanics of programming for these consoles. And sort of, you can also explore like the unique graphics capabilities and really limitations of each of these consoles as well by doing this. So the starting point for this was a game called Jetpack, which my brother and I, growing up, were obsessed with. It's this platformer where you're a tiny figure here, with a jetpack with a limited amount of fuel. And you're just running around this maze sort of collecting gems. It's like Pac-Man if he had a jetpack. And I thought this game was endlessly fun. It's relatively simple graphically. It's sort of like a 26 by like 20 grid. And it had a level editor built in, which I thought was the coolest thing as a kid, because you could design your own like mazes and traps and things. And you had enemies that went around, and basically it has all the features of like a standard game, without being too complex graphically. Hi, this is a Pax Consola talk, if you're interested. Yes. So this was a game I sort of started out with, and I was like, all right, let's see how many consoles I could port jetpack.exe to. So I tried writing one. I started with the hardest console first, which is the Atari 2600. I think there's a talk later on today about, yeah, right now, the next talk is Atari 2600 programming. Very limited console. It could do 2 sprites, some playfield graphics. You're lucky if you get anything like usable out of that without using a lot of processor tricks. And I actually did a demo which is like sort of functional. You can fly around and collect like 2 rows of gems. Then I ran out of RAM and I was like, all right, this is hard. So it was a difficult process. But while doing that, I sort of evolved the project from jetpacks to jetpacks. And then I came up with Pax Consola, like a piece between all consoles. How do you build a game that can run on any of these consoles? And I realized that the interesting part was like writing the graphics, not really designing the game logic or anything. In fact, the game logic was the same for all these consoles. The tricky part was actually the assembly part. And yeah, I built an Atari demo out of that. It's actually kind of playable. But obviously there's a big difference between the thing on the left and the thing on the right graphically. So I didn't necessarily get that far. So I decided later on, I was going through other programming resources, and I was like, all right, well there might be something simpler I can start out with rather than a complex platformer. What about Snake? Snake can run on a Nokia phone, it can run anywhere, I'm pretty sure. And I was actually looking through a tutorial on, this is a very low resolution graphic, but this is a tutorial called Easy Fourth. I found this on like Hacker News one day, and I was like, wow, Fourth is really intuitive if you're trying to build something for a small console. And inside the same tutorial, they also had an example of Snake, and I was like, all right, well, if I could build Snake 4th and bring this to more than one console, that would be pretty cool. That would be a proof of concept that I could bring one game to all these different consoles and maybe work my way up from there. So the project started out literally as a way to take that 4th game that you can find in that URL and port it to different consoles. Sort of the approach I took also is PaxConsola.com is an IDE. This is mostly for demonstration purposes, but also I wanted to take a different approach than other really good websites that sort of do the same thing. If you go to 8bitworkshop.com, that's a great resource for literally getting out of the box, started with assembly on Nintendo, Atari 600, a bunch of old arcade machines. It's really cool, but the problem is, of course, you're starting from scratch in assembly. You're not really able to understand what you're working on unless you dig into the mechanics of the console. So while that's a good process, I was like, well, what if I took the exact opposite direction and made it so you only write one game and it runs on many different machines? So I started out Pax Consola on the Game Boy and the Commodore 64, and when they said VCF was on this year, I was like, all right, well, let me try to pivot quickly into what the themes were for this year, which is the legacy of the IBM PC and text adventures. So now I want to give a demo of the website. Open here. Cool. And forgive me for the small VGA resolution. So if you boot up into this page, this is going over my phone Wi-Fi, so hopefully that works. It's very straightforward. You get booted into an example of Snake. This is very similar to the one on Easy 4th, that tutorial there. But basically, the pane on the left will set you up with your 4th game. And I will explain a little bit later about 4th and how that programming language is both uniquely suited and not suited for this project. But this basically sets up your Snake variables, some drawing routines, draws the walls, draws the snake head, and then manages a game loop all the way at the bottom here, where you initialize all the background graphics, and then you have basically a tick for every next frame. So you don't have to do anything when you load up the page. All you have to do is click a machine you want to run it on. So this will take a little bit. Launch an emulator. And now I'm playing it in DOS. And so that's great. So Snake in DOS, that's pretty fun. Obviously, this is a text mode game. I kept it simple for this first example because I wanted to be able to show running it on many different consoles at once. So I'm bored of programming for DOS. I want to instead try a different console that I grew up with, the Commodore 64. And what this is doing is actually compiling it in the browser right now and then launching this. And here we go, an equally fast version of the Commodore 64 Snake written in a high-level language. And then finally for the Game Boy, those are the 3 targets that I designed for this example. And the Game Boy is a little slower. That's intentional to show how we optimize them, and I'll talk about that a little bit later too. There you go. And if I wanted to, I could actually go ahead and modify this basic example for now. Let's say instead of having a snake that's 4 pixels wide, let's see if we can set that up. Yeah, so 4 is the length. Let's say it's actually like 12 characters wide. I'll compile it for DOS. And now we have a massive snake that's literally eating through the walls. So what do we get with that? So high-level language, you're able to code something and run it on multiple machines. That's pretty neat, but how useful is it? Back to the top. So to start with, I want to say why I chose these 3 consoles. So like I was saying, I think vintage graphics has a huge nostalgia element to it, especially like the growing up on certain machines. I grew up in the 90s, but for some reason we were using a Commodore 64 until like 95 or something, even though we had like newer machines at the time. So that one's very fond in my memory. We had a ton of games for it. The second machine that I was targeting is DOS, and particularly like an 8086 DOS, so something that was like new out of box in 1984. This machine that my dad had was a Zenith, formerly a Heathkit machine. I did a lot of arcology on figuring out exactly what we grew up with, because I hadn't used it in a few decades, and there are a lot of different DOS machines. And then lastly, the Game Boy. Obviously, grew up with that in car rides and things, and I always wanted to write a Game Boy game. DOS one was interesting. I actually whipped this thing out of storage. And my dad actually had built this machine in 1984, I found. I couldn't ask him, but this was a huge investigation. And he had upgraded it at least from a CGA machine, which is like, you know, the standard like 4-color graphics that you can imagine being like really gaudy colors. Added a VGA card, so it could do 256 colors. Added a new, faster processor, the V20 and things. So when I started this project, I was like, oh, it's going to be really shitty having to build like a DOS game that looks really ugly. And so I built a lot of my thought model around that. And then later on I discovered, I was like, oh, actually my dad upgraded this. I didn't need to do any of those limitations at all. So I split the difference a little bit later. But yeah, so, you know, as I said earlier, it's like your medium sort of dictates what the graphics capabilities are and sort of what your game design is. If you're taking an approach where you're running the same game on many consoles, it might be pretty interesting and may not fit exactly what you would be the optimal experience for each. So here's an example of the game Lemmings, which has been ported to almost every console that I'm interested in. Probably fewer than an average text adventure would have been, but still, and for a graphical game, it's pretty good. And you can see sort of the difference between like the Commodore version, which is like 2-pixel wide graphics, very low color resolution, to the DOS EGA version, I think, which is like high color, and that's the one I grew up with, to the Game Boy one, which is like grayscale, and you can barely see the tiny little Lemmings characters running around. And I thought the next thing I wanted to explore after Snake was like, all right, making a text adventure game is pretty fun, but let's see what the graphical capabilities are of the machines that we're working on. So the next thing I worked on for this project, the first one being Snake World. The next game was called Sword World. So on this same page, I can actually drop down to this game here. Load the example. It's very short right now because it's a graphical demo. But in DOS, I built a game engine to sort of play around with this idea of, oh, can I make like something really compelling and tile-based with like graphics processing? So this was kind of tricky to get together. DOS does not actually have like a tile mapping system. And I was also writing for EGA because again, CGA came out in like the early 80s, EGA was in the mid 80s, that's what I thought I was targeting. VGA came out in the late 80s, would have been a lot easier. But I went in and I was like, well, let me build a tile-based game in DOS to start out with. And you'll notice that like on the left here, there isn't any configurability. This is a work in progress demo, so it literally took all the time I had to build this game engine, especially because it's tricky in DOS. But this is also something that I wanted to port to Commodore 64. And sort of here you can see like the graphics resolution bit is a lot different with your main character. It's a lot more limited. And the same would be true of the Game Boy. But I wanted to start out exploring what the graphics capabilities would be and how you build a game engine that can run one game on many consoles when you're having full resolution graphics. And the two things that you might notice are like, okay, well, your graphics aren't really part of your game. They're like something separate you design for your game. And separately, like the game map is also not code either. It's something separate that you add to your game. And so you start to see like, okay, building an interesting game in these consoles requires a lot more than just being able to program for them. It requires like an asset pipeline, being able to design levels and things. So that's still a work in progress, but I'm overly satisfied with how far I got on DOS and making something that looked attractive and that could run on a machine from like 1986 if you had a 8086 running on it. So this is running a DOS box and it seems pretty capable. configurability is this really weird question when you're going in and being like, oh, so I have one game and I'm trying to run it on a lot of consoles, but you know, can one game actually be fit to all these different models and all these different resolutions? And the example I want to give is like, this example here for DOS, it's like, if you divide the screen into 16 by 16 tiles, which like looks attractive on those platforms, you'll get like 20 tiles by 12.5. But then if you're doing it on the Game Boy, if you're trying to subdivide it into 60 by 16, you get like 12 by 9. It's literally a fourth of the resolution of what you can display. And so you actually don't have the choice of like building something that can look pixel perfect on every machine. You actually have to adapt to it. And that's why the snake example was wicked easy when I started with it. It's like, yeah, you just draw the box on the outside of the screen, your screen's as big as it is, and whatever. You just have the character move around however much space is available. But building a complex game is harder because you have to think about, okay, what's it going to look like on different resolutions? And in addition to that, like I mentioned, there's differing video standards for DOS. It's like, do you make a game that is compatible with the oldest DOS machine, CGA, which would be kind of tricky. You have limited color resolution. You could do some tricks to make it better, or EGA, which is the machine I thought I was targeting versus VGA with full color. Do you make it compatible with all of them? Yeah, and there's also obviously different palette resolutions. It's like, can you design a graphics system that works in DOS with full color graphics that's also going to look good in 4-bit grayscale? And if you decided to be crazy and port it to the Atari 2600, you'll probably have 1 bit of color, black and white, and is it going to look good in that environment? And like the biggest drawback that I saw is like, you can't make something which is fixed to the size of the screen without reinventing the wheel every time. I was really excited to be like, oh, I want to build like a Zelda-like platformer for, this is Link's Awakening GX for the Game Boy, which is one of my favorite games growing up. But because the resolution of every game you're going to build is different, you can't build something that's going to be specifically the size of that screen. You can't build like a puzzle game that's going to rely on the size of it. So, had to think broadly about this, and it's like, what do we do about this? You have to make games engines that are compatible with many different resolutions. So here we decided, okay, we're going to just do a scrolling map. So you do a top-down scrolling map engine that your screen can be infinitely wide or infinitely small, but you just pan around what you're doing. And that's the limitation of it. So as I went along, I was like, all right, how do you actually abstract out what these different engines do? I came up with a naming scheme, should be obvious. But the two engines that I'm showing today, the first one is Taurus. So that's for text-based games. That's for Snake, which is very simple. You're just drawing ASCII characters on screen. And interactive fiction, which I'll talk about in a second, like Zork or any adventure game. And then Libra would be the graphics engine. So top-down scrolling engine using tiles and sprites. And like that's something you can map to a bunch of different consoles. No matter how many sprites or how few they have, you can make your engine sort of adapt to it. And I thought of at least 2 other things that I could be exploring as like the core of the game that's not written in Ford, that's written in assembly. One which is just powering Jetpack, because I still am interested in porting that to a bunch of machines. Could be powering Jetpack or Pac-Man or any game where you're just collecting jewels, basically. And then another one would be like, oh, all points addressable, so you can make like drawing games and stuff. And have that run on any machine. You can invent Mario Paint that runs on a ColecoVision or that runs on a Super Nintendo, but using the same code. Well, so I want to talk briefly about Forth. I made probably not an unconventional choice, but like certainly one that not a lot of people are familiar with. Forth is a programming language that is stack-based, and it's different than I think probably some of the choices I could have been making. So this language is like pretty nice and terse, but definitely harder to use in your average language. So if you start out from thinking like, okay, what is a high-level language? Like, what are people writing their games in? Well, if you're booting up a Commodore 64, you're literally booting up into BASIC. So that's sort of the OG sort of thing. It's like, oh, I'll design a game in BASIC, and I'll poke and peek at different like values in the game system, and I'll build a game out of that. And maybe that's portable to a bunch of consoles. And I know that I actually grew up on DOS QBasic and wrote a bunch of like half-baked games as a kid in that. And maybe a more modern example is Atari Basic for the Atari 2600, which is like showing that you can use a high-level language for a system that's very constrained. Seen a lot of good examples of that. But I chose Forth, and so why is this suited for this project that I'm working on? So here's my high-level overview of Forth. It's the first time I've ever tried to walk through what the language looks like. Hopefully this is understandable. So the quick look is that it's an easy to parse language. Everything is a token. You don't need like huge AST trees in order to understand it. You could literally write a Python script that's like split all the white space out and then just interpret it character by character. It's kind of cool. It uses reverse Polish notation. I'll give an example afterward. And if you go to the actual IDE, you'll see a lot of backslashes and parentheses, which is sort of confusing. Those are comments. Forth decided to use a backslash instead of like a semicolon or a hashbang in order to say what a comment is. It's a little tricky, but then it becomes understandable once you're looking at it. Functions are very easy to write inline. You start them with a colon, you end with a semicolon. And yeah, but the actual unique part of the language is there's two stacks. There's a data stack and a return stack, and all operations operate on one of those. So the most basic example of Forth, like I said, reverse Polish notation. You're writing your operators sort of after the inputs that you actually have. So instead of 2 plus 5, you're doing 2, 5 plus. This makes sense because what you're actually saying is when you write the character 2, you're pushing 2 onto your stack. Then when you write the character 5, you're pushing 5 on top of that. And then when you hit the plus sign, you're saying add the 2 top numbers on top of the stack, and you'll get 7. There are 2 stacks in Forth. This is fun. You can shuffle them around. If you've ever played like the game Code of Hammurabi, it's sort of like that. You're moving like values from one stack to the other, and it's sort of a puzzle. But in this example, we're going to do 2, which is pushing 2 on the stack, and then these 2 characters, caret R and R caret, actually move stuff from the data stack onto the return stack and back. So here, we push 2 onto the stack, and we say move the first value from that stack to the other stack, the return stack, push the value 10 onto the data stack, and so now we have 10 and 2. And then we can pop it from the data stack. So this is basically push and then pop. And then we'll have the reverse of what we put in. So we put 2 and 10, and we actually line up with 10 and 2. And then you can do an operation on that, like subtract the top 2 values, and we'll get 8. And then a few more examples here. If you're reading through the source code, this might be helpful. You can declare a variable using the word variable. And then you can write to it using the exclamation point, and you can read from it using a @ sign, and that's sort of your read and write operation for any value in memory. And the Snake game actually does this a lot. It uses, it writes a lot of values to memory for your Snake array and then reads from it. So using memory and Forth, you can actually build an entire game like that for an individual console just by like peeking and poking memory addresses, very similar to BASIC. And then here is an example of a function. We can declare times 2 will actually duplicate the top value of the stack and add them. So adding the value to itself, multiplying it by 2. And then lastly, here's an example of a loop. We declare that we want a value to go from 0 to 10. And then the values, the words do and loop will allow you to iterate over that. And every time it's going to run this inner bit here that says push the iteration loop onto the stack using the value I, and then print that value. So there's a lot more I could go into Forth, but again, I wanted to explain why I'm doing it this way. Because this is really easy to write, it should be easy to compile to a lot of different processors, or that was my thinking at the time. We have a lot of different examples here of different processors that we're using for these different consoles. They all sort of have the same origin if you get down deep enough, but they're kind of dramatically different in some ways as well. The 6502, so that's what's powering the Commodore 64. It's powering the NES, it's powering a ton of other game consoles from the early 80s and late 70s. It's powering the Atari 2600. But it's also wicked limited. You have 3 8-bit registers, so you can move values into 8 bits at a time. And the Forth that we designed is actually 16 bits, so that's a nightmare because you're trying to stick. You can have at most like 1 value in those registers at a time, 1.5. It has a hardware stack, which is good, but we need 2 stacks, which is bad. So this is a very limited console, for example, and takes a lot more processing power than maybe the next one. The 8088, I've never done x86 programming before, like PC programming. I actually found it really enjoyable, to my surprise, because it has 4 16-bit registers. Moving stuff around was actually kind of really easy in this environment, and compiling code was easy. And it has the ability to have 2 addressable hardware stacks, which we have 2 addressable hardware stacks, so that was nice. And then the Game Boy uses a Z80-like processor. It's also like the 8080. And again, it's 4 16-bit registers, so that becomes nice. So what are we doing here if we're trying to run forth on all these different machines? Like, is this cross-platform assembly? Are we writing a high-level language that compiles to like really low-level code? Not really. This is the example for multiplication, and this is literally like loop over the same value many times and then add it a bunch of times, and that's multiplication. Like if you were doing it by hand, that's sort of like what it would be rather than memorizing it. And then this is a giant code listing for what it looks like on the 6502. Because it has so few registers, trying to just blindly encode that value into this assembly code is really expensive. Forth is hard to optimize. There's a lot of dynamicism in it, especially for these older consoles. Most of the implementations that I read for Forth were like, well, we're gonna like do an interpretive language so you can at runtime like dynamically do a lot of stuff. It was super cool, but for this project I needed none of that. I actually needed the code to run fast, which is kind of bad. So Pax Forth, the language that I implemented for this, doesn't use anything like immediate mode or like Forth modifying Forth, let's say. So it's ahead of time compiled. So we really are trying to use it just to compile down to like assembly code and have it run at some reasonable speed. What I'm actually doing is probably using it more like a virtual machine. And so again, the second theme to this festival is text adventures. And one of the examples of text adventures is like Zork and the Infocom games. And they use a virtual machine called the Z machine. So a contemporary machine at the time that someone ported to a bunch of different consoles and ran the same bytecode on. And so Pax Forth is sort of like a virtual machine in that we're taking this high-level bytecode, we're trying to run it on these systems with limited capabilities, but we're trying to do it in a way that's fast enough in order to power the game logic while kicking everything else out to assembly code. In the Z machine, it's kind of similar. They use a high-level language called ZIL, or if you're using a modern thing, there's a much nicer language called Inform you can check out. But like back in the day, they were using this high-level Lisp-like language called ZIL to run the game logic like Zork. And it powered a bunch of different text adventures for those machines. The Z machine didn't have to do that much. All it had to do is sort of take in an input line of text and then interpret it, parse it, run some functions, and then go back to the user for input. And I thought this was like kind of similar to the text mode that I showed for Snake. It was like, oh, well, you know, the Z machine is kind of just doing a bunch of text operations. In fact, in later versions of the Z machine, you could probably write Snake to run on those consoles. I'm not sure if anyone's done that. I'm not doing that today. Instead, I did the opposite, where I was like, what if I make a text adventure in Forth and try to demonstrate that? So that's what I'm going to show right now, actually. The last demo I have today is, I showed Snake World, I showed Sword World, and now I'm showing Fork World. And unlike the last game, which is the graphical demo, this actually has a ton of code running in it. And you can scroll through it and actually change what it's doing if you're trying to add new capabilities to your text adventure. Basically, here's my Forth code running in DOS. We are entered into a room. The room contains a crowbar and a chest. We're going to take the chest. We cannot take the chest. We're going to take the crowbar. We take the crowbar. Check our inventory. We have a crowbar. Text adventures in a nutshell. This is very limited. I got this working like this week, but the fun part about it is I really didn't have to modify anything. All I had to do was allow text input. And this does all the heavy lifting instead. You're basically setting up a bunch of static objects and parsing the input that you get, splitting it up into tokens, and then running it. And I thought it was really cool to like sort of see how the parallel between running a game in like the Z machine or a game that was running for like these text adventures could actually be broken down into something that was literally just written in a language, a high-level language like Forth, and run on these little machines. So I didn't get this working on the Commodore. It actually takes up too much space right now. But the idea would be that with optimizations turned on, that this could run on any machine, and you have something similar to the Z machine actually running on a bunch of consoles. And just to sort of hammer that home, I thought it was really cool to like actually dig into how those machines worked. My understanding of the Z machine was like, oh, it does all this parsing for you, all this logic, you know, it has all this stuff embedded. It's actually really straightforward. It leaves most of the stuff to the game. It like converts your keyboard input to a lookup table. But we can write that before. We just have a giant branching function and you're good. Then it identifies like a direct object and an indirect object, and then it invokes an action. And then it tries to do one of three things. It acts on the player, the object, and the action itself. And then it either modifies stuff in the game or writes some output to you. And so I literally was like reading through Z machine manuals, and I was like, yeah, I could copy this into Forth and try running it. And it actually worked out pretty well. As a scalable model for writing text adventures. So that would be something cool that I want to follow up with, basically, is making a full-fledged game.
We're doing all sorts of...
So lastly, I want to talk about what Pax Forth actually looks like. So we're writing one language, we're trying to bring it to a bunch of different consoles. And I said it was sort of like a virtual machine. Well, virtual machines have opcodes, and those opcodes you compile to a bunch of different machines. And this sort of came out of a project that I saw called Nibbleforth, which is like, here's 12 opcodes to getting a programming language running. You only have to implement these 12 opcodes to get it running on any machine. I was like, well, that's compelling because I don't want to do a lot of work if I'm trying to bridge a new console or something and get it working. So Pax Forth uses 16 opcodes, mostly like stack operations, literally only 2 operations for adding and nanding numbers. Everything else is written in Forth, which makes it slow, but we'll talk about that. And then a bunch of branching logic, like if you need to loop, or if you need to like jump, if then else, or exit or call into a function. So out of those 16 plus 8 opcodes, 24, I ported all those to the 6502, Z80, and 8086. Those opcodes are very easy to like bring to a new language, and you sort of get your feedback about like, well, okay, I'm trying to port it to like whatever the TI-99 machine. But I was trying to the TNS chip that uses, for example. I would just have to go through and be like, all right, can I prove that like adding works? Great. Can I prove that nanding works? Great. And you sort of build up your repertoire from there and make sure that a game works. But you only have so many opcodes you need to deal with, so it's not like you're building a whole new compiler for a new system. You're really just building like a translation from opcode A to a few lines of assembly. But obviously, like this is super slow, and so I decided to fall back on, you know, if all the graphics routines and sound routines are going to be written in assembly, we might as well write the hot code as well in assembly too. So when I showed you the Snake example, the Commodore version and the DOS version are really fast, and the Game Boy example is really slow. And that's because for the DOS version of the Commodore, I decided to write a native multiply routine. And when I did the Game Boy one, I ran out of time. And so the multiply routine is like, okay, so I have X and Y on the screen. I need to find out like where on the screen that is and write a byte to there. But if you're actually trying to figure out like in a linear array of bytes, which is what your screen probably looks like, how far down in it you are, you're basically multiplying like X by Y, or sorry, screen width by Y plus X. And so to say that again, it's sort of like, in order to find where on your screen you draw a pixel, if you get an X and Y coordinate, you need to run a multiply function. And if you're doing that in Forth, it's going to be wicked slow. So for DOS and Commodore 64, I wrote a way to just be like, all right, just kick out to assembly, do it fast, and then you get a game that actually runs like fast enough on Snake. So to wrap up, I want to talk about the website itself. So PaxConsola.com is an IDE. It was hard to get it working in time for a showable demo. It still has a lot of flaws, but I think it's really cool how the stuff is stitched together. So I just wanted to sort of pull it up one last time here. if I refresh the page, go into like this basic snake world example, and I click DOS, and it starts loading this emulator, a lot is going on under the hood in order to play this game. So there's no server that's actually compiling any of the stuff that we're working on. It's actually all done in the browser. And I started out this project by having, basically working from the command line and running like a bunch of compilers and stuff, and then you can like boot into an emulator on your computer as well, and have that all work. So how do you get the stuff running in the browser instead was the big question. And it took a few different pieces. So unique tech facts, the entire site is written in Rust. This was arbitrary. I decided to try a language that works really well with WebAssembly, and WebAssembly is a way to run like native code, especially C code in the browser. And this is sort of essential for this project because I wanted to take all these compilers, some have been written decades ago, and make it so you could just like, with one click, actually run it. And so this website actually is using cross-compiled versions of those assemblers and running them in the background. And so it'll be like, for DOS, there's an assembler called NASM, the NetWide assembler. And so it's actually running that in a background thread. It converts forth into assembly into a binary, and then it sends it back to your browser and says, all right, well now we're going to run it. And so not only do I have to solve the compiler part, which is compiling binaries or like potentially decades old code to run in your browser, we also then need to emulate the machine that you're running on. So the emulator part was actually really cool. There was a project a few years ago called Emularity, which if you go to archive.org, you can actually find a ton of like old video games there that are freely playable. And no one's actually going to get the copyright for them, or they're archived for preservation purposes. And what they did is have basically one library where you can run a bunch of different old machines at once. Sort of like MES or MAME for the desktop, but in your browser, so anyone can use it. And so this project called the Emularity is actually running DOS and the Commodore emulators that I have. The Game Boy one is actually a different emulator that I found online that also runs in the browser. But luckily I was able to reuse other people's work to get the systems running in the browser. All I had to do is provide an environment where you can write code and then run it. And like browser emulation is really cool because I can actually go up and look jetpack.exe, and I can go to archive.org, find this game, click play, and I'm starting to play it. Which is again one of the like really compelling things about putting this all on the web is like, all right, well, instead of fussing around with command line or making this really inaccessible, you can make it a one-click operation to try to get something working. And the whole point of this project is to try playing around with as many things as you can. Try to have more experience with like all these old consoles, what it's like to code for them. Removing the barriers to entry, so to speak, about actually getting stuff running. And it's also wicked fun, so I definitely recommend looking up your favorite like childhood games on archive.org. So lastly, like the technical challenges here, there was a lot of research required, like at every step of the way, a lot more than I had expected for some parts of it. Old systems use a lot of unique technologies, but documentation is sparse, and like I feel like it's gotten more sparse over time. Even though there's so much more information available on the web, it seems to be harder to access it for some of these old systems. And I'm not even talking about like crazy old, like here's the manual for the IBM EGA adapter. That's how you get graphics working on the DOS machine that I grew up with. And like I had to pour through a PDF of this that I only found in one place just to even like debug what the graphics errors I was getting were. And then there's a whole manual for like learning the Z machine, learning how you write text adventures for Infocom. That was written in 1989. It's literally like scribbled with notes being like, hey, other editor, can you fill this part in? Because I don't know what it is. And of course they never filled it in. This was like when Infocom folded, they found a PDF and they're like, all right, I'll throw that online. So you get really creative with what references you're using. There might be a better way, but I actually found this like really exciting to go through old PDFs and be like, well, yeah, I'm using literally the same manual that someone would have used in the 80s to try to make this machine work. And surprise, it actually has a lot of the answers. The other challenges are like, how do you make this niche creative process of like making one IDE that can run a game on every console accessible to people? I tried putting it online. That might be the right answer. Maybe there's different answers. Maybe there's better ways to show how you make these old consoles accessible. And lastly, this is sort of a work in progress. Like if you use a website, it's pretty buggy. And I didn't get as far as I wanted to for this talk. I maybe started in earnest 2 months ago, and I still only got a lot of stuff working this week. But I'm really excited for having all the bare bones stuff now about like, okay, what does it actually take to write an original game? I showed you a graphics demo of a character walking around a screen. I want to make it a full-fledged like RPG, Sword World, where you're like walking this character around and where it can run on all these different consoles. I want to write a full-fledged text adventure. Like I found it really cool to learn how those text adventures from the 80s worked, and sort of like how far you can get with really limited technology, just text mode on your screen and character input to make an immersive game. And I found myself playing a lot of text adventures, which is cool. And then lastly, it's like, well, probably the coolest part about this is like, I did 3 machines, which is DOS, Commodore, and Game Boy. Well, there's other harder challenges, like I could write an Atari adapter. That'll be really hard to do good graphics on the Atari. Here there's a talk coming up on that. There's also other consoles that I grew up with. Like at the same time we're using a Commodore, we had a PlayStation 1, which is kind of an anachronism. But I always had a fondness for the PlayStation. Like you could look up the instructions on how to code for that. They're equally obtuse. But it's really cool, all the tricks that they had to do to get stuff working. I would love to be able to port a game to that as well. And then lastly, where I started out from is the Channel F. And this is actually a homebrew console, not made by myself, but like some of my code is running on it. And I have a physical copy of that. And it's actually a burgeoning industry to get games burned onto cartridges that work on real machines these days. And I would love to get like an actual console or cartridge version of some of the stuff that I'm writing right now. And that's super doable. Probably the Channel F is, again, one of those things where you have to read a lot of old technical manuals in order to understand and make something good. But it seems like an exciting challenge, so I'm excited for it. All right, that's my talk. Thank you all for coming, sitting in, especially if you can definitely let me know if there's something I can explain or whatever. But that's Pax Consola. I invite you to check it out or check out the source code. Yeah, thanks again.